Welcome back to the Micro One forum. We took a bit of a few weeks of a break from the last time that we ran the episode. I think summer kind of helped us to justify a bit of a break, but as we're kind of ready looking at the kicking off of everything that is happening towards the end of summer and beginning of September, we wanted to start with an all-star panel and on a topic that is becoming hotter by the day, where all of us are being more and more exposed, but we don't have the degree of knowledge and insight that we have that our guests have today. So I'd like to welcome the three panelists for today. So Arian, who is a colleague from Micro One. Arian is the VP of Robotics at Micro One. So Arian, nice to have you back on the panel, Arian. You've been on the panel before. And I think just from last time where we were talking about robotics, so much more progress has been made in the industry on this. So at Micro One, you're kind of leading this large-scale human and robotics data collection that is kind of helping to structure pipelines that are powering frontier robotics labs and AI research. And you this is this and more, right? But this is definitely a large part of your responsibility in doing this. And nice to have you back. We have Derek, who is working for Odyssey. Derek, you had done many different things even before. You were working at Cruise and then Uber, but now at Odyssey, if I understand this correctly, is really building general purpose world models for interactive simulation gaming and robotics. So there's a lot of nuances for the work you do that we want to tap and go deeper and learn from. So very happy to have you, and then welcome to the Micro One Forum. And we have Sam, who is the head of our World Model Lab. Your name company is 1X. So you were Luma AI before, if I understand this correctly. And so if my interpretation of your work, Sam, is correctly, now you're leading the lab and you're focused on large-scale embodied world models, pre-training to basically power autonomous humanoid robots, which is something that, again, many people might have heard about, but again, the knowledge that you guys have is a match in comparison to where people are making the first steps. So first of all, Aaron, Derek, and Sam, welcome. Very nice to have this conversation with you. And as it has always been the case, I am the one that probably benefits the most from the interaction because I can see the conversation unfolding as they happen. So thank you for being here. The way I wanted to plan today was first to establish for people who are listening to us today, both in terms of live and the recorded version that will be available afterwards through different channels, what world models really are and why are they emerging, right? As a complement to language models. Many people cannot even make that connection currently clear in their mind. Second, I'd like to go a bit deeper into the technical and operational specifics. So how they're built, what is the data that they require, how do you evaluate them? So this is more related to what probably also defines the quality of the model that we're training. And third, it will probably be where are we going with all of this, right? Where are the trends eventually shaping the direction of travel? And I think there's more and more of combinations and configurations that are happening in robotics that are becoming so critical for us to understand. And so we'll try to tap on the direction of travel as we kind of wrap up. For everyone else watching this, the Micro One Forum is they're participatory, they're interactive. There are many people that eventually will want to put questions in the chat or yeah, I think it's a chat in this case. Do that, please. My colleague Haley and Sydney, they will keep an eye on the chat. And even if I can't keep up with everything, I'll be able to be prompted on maybe some of the questions that are worth for us to flag to our speakers. We try to have the first half an hour kind of dedicated to the conversation that the speaker are going to bring forward. Then we'll have the last 15 minutes for Q&A. So great. Arian, over to you. Very nice to see you. I'm happy that I met you in person as well, and I'll see you very soon in San Francisco, hopefully in the event we're having on Thursday. So look, I start from you because I think for people who are, who work currently in AI, right, but they haven't gone deep on world models. If you had to tell them what is the kind of a problem that world models are trying to solve for robotics that we can't do with language models, because I think for many people, they think it's interchangeable. And of course it is not, but they don't necessarily know what are the differences, right? So tell us more about robotics, world model, what also constitute a lot of your everyday work at Micro One.
Yeah, of course. And thank you for the intro and thanks for having us and moderating. I would say the thesis behind world models is actually why we kicked off robotics at Micro One in the first place, which is there are several environments that exist in our world, and LLMs have done an incredible job at kind of handling our needs within this one environment, which is your, laptop or computer and everything you do in your screen day to day. But if you look past that into basically any other environment, it hasn't been solved with the exception of some progress made in FSD and self-driving. But there isn't really any full autonomy in these several other environments that exist in the world, right? So if you want to move past text, there is sort of this need for additional data inputs and use cases that can help automate all these processes that exist in the world. So, right, so if you look past text and if you want to apply it to robotics or any sort of embodiment, that just helps make daily world tasks more efficient. You sort of need this progression past LLMs, and you need for that to be made possible. You not only need all these sort of different modality plugins of data, you also need to know how to make existing data more useful with sorts of structuring and post-processing done. So this is sort of the kind of convergence of, okay, how are we going to move past, I think a lot of the LLM use cases are still useful and applicable towards the progression of world models. I see it more as like um, just like an evolution, all right? So you take your existing policies and then you add in all these kind of new world environments and then try to create some sort of model that can have a better general understanding for the world, the same way we do as humans.
As humans. So Aaron, this is great. I think it's a great way for me to start kind of set in the pace also for Derek and Sam to help us with their own view, right? And you mentioned the fact that we are trying to get as close as possible to how we can use this model in the real world. And so, Derek, if I pass it over to you now, if I understand correctly, somehow you're working on some form of world model as a general purpose, which kind of meets the kind of the direction that Aaron was explaining. But when you're thinking about what it means technically, right, a general purpose world model, does it mean that the model has to learn physics, aesthetics, interactivity? So I think help us to understand when you're talking about general purpose and the context of world models, what does it mean? Because I think for many people, we might understand general purpose like we might understand a technology that was a software, right? But how does it become general purpose when it's more in a world model?
Yeah, that's a great question. I think uh, primarily by consuming vast amounts of data. But I think there's also like an architectural distinction here for how that data gets translated into the experience you have of the world model. And at Odyssey, we think that means a causal action conditioned autoregressive model. So autoregressive means it's building its output one piece at a time, where that piece depends on everything that was generated previously. Causal means it only looks backwards and at the present, never forwards. I think that's a distinction with bidirectional models. These are the video models that you interact with when you produce video clips, where it's taking like the start, the middle, the end goal, and building it all at once. Um, and then action condition, which means the future prediction depends on the action that you're giving it. So you might seed the model with an image of a cup on a coffee table, and
Mhm.
the model will continue to produce a cup on a coffee table. But if you ask it to push the cup versus pull the cup, it influences what happens next.
Mhm.
And then diffusion transformer, I think, that is similar to like the legacy video generation models where we just start with noise and gradually refine that into an
Mhm.
image or a frame that represents an accurate prediction.
Yeah. There, if I can give you like, I ask you for a short follow-up, right? When I was kind of preparing for this and I was looking at your kind of work, I saw gaming is also part of your background, right? But for many people, the connection between a general purpose world model and gaming might be too far, right? To put together. Why is gaming pertinent in this case? Can you help us make that connection as well?
Yeah, I think gaming represents a controlled environment that's low consequence and is ripe for interactivity, right? They're worlds you can explore and you can interact with at low stakes. And when we think about this timeline from like where we are now with what models are capable of and what they can generalize, um, I think entertainment is one of the platforms that is most mature. Now, we still have a long way to go, but being able to explore and interact with worlds in low stakes environments is one application that sort of represents what models are capable of today.
Great. Well, there, I have more question coming to my mind as I listen to you, but I'll try to hold my question for the next round, right? Because I want to make sure that we kind of get the first round of exploration also with Sam, with the work that Sam does at 1X. Sam, I'm going to give you some context. Yesterday, I was being interviewed by MIT Technology Review for a piece they're writing, and they asked me a question whether fine-tuning language models was okay for robotics, right? And I'm not an expert like you guys are, right? And my answer was something around you can't necessarily mix the two by thinking they're fully interchangeable. To some degree, they're fundamentally different. And so it brings me to a question where I think you're quite clear that pre-training world model requires almost an effort from scratch, right? And this is a challenge that many people don't necessarily understand. Can you help us understand what was the evidence that started to push you to think that the effort was not necessarily incremental, adding on, but it requires an entirely different set of posture and direction as well? Love to hear your perspective on this.
Yeah. First of all, thanks for having me. That's a great question. I think there's nothing fundamental or fundamentally wrong about, taking a pre-trained LLM or VLM and then fine-tuning it on robot data, right? It's not fundamentally wrong. I just think it's fundamentally limited, right? Like there's some nuance there. Language models, like what Arian was saying, is that they are very good at coding and math, right? So they're able to model the temporal coherence, temporal dynamics of things very, very well, but they're not modeling the explicit physics in the world, right? And there are just like significant shortcomings that we have seen time and time again, that these models are not able to generalize, they're not able to model the physics really well, new environments, new settings. They're not able to kind of one shot generalize to novel situations super well. So the issue, or the nice thing about thinking about how to build these world models, is to basically break down the bigger goal of where we want it to be, right? The obviously, right, like Odyssey, 1X, right? Like there's a ton of companies working in this space, right? Like how can we get a general purpose agent that can power a robot, possibly also power game engines, right? Like how can we have some sort of general purpose world action model, world model that can model physics, right? And to me, the reason why 1X is betting so deeply into gaming and thinking about world models from first principles is actually that we want to make sure that these models have the right priors, right? There is tons and tons of unimaginable amount of more image and video data on the internet to learn from than there is text data, right? Like, if you were to just look at how much gets uploaded to just, free streaming websites, it is much more data than any human can ingest, than, basically all human cumulative experience can even ingest, right? The mission at 1X is how can we actually do learn from this data, right? There is tons of data. 1X is uniquely situated, right? Because we have Neo, which is a humanoid robot. It can, our bet is that a humanoid robot can best learn from human experiences, right? When you have so much data of like, humans interacting in scenes, humans interacting with each other, humans performing tasks, right?
Mhm.
You're best situated to learn from that data, learn some meaningful skills, meaningful physics, meaningful interactions. I think there's two, like broad strokes things to learn with world models, right? Like how can you learn physics? How can you understand, the temporal dynamics of things? And how can you learn causality, right? Like when you interact with the world, when you move something in the world, how does that actually affect the world itself, right? If I have a cup and I pick it up, right? I am fundamentally changing the state of the world, right? How does that actually affect the rest of the world, right? So there's those two different things, right? Causality and physics, which I strongly believe that we can learn from data and interaction. And the broad pitch of world models is to be able to learn from these very very rich experiences that we have with petabytes and petabytes of scale of data, and yeah, the goal is to really find the form factor, right? Like Derek was really going into what the form factor that they're trying to build at Odyssey. I think that's incredible, right? Like there's definitely the space of solutions is quite large. VLMs, LLMs, right? They are a plausible solution. What Derek was
Mhm.
pitching, I think it's maybe the higher ceiling solution, but empirically speaking, right? Like the solution that Derek was like suggesting was what we have found and what the industry has found is that it's seemingly able to generalize more. It's seemingly able to like generalize from like novel tasks, novel data much better than VLMs. So that was a long spiel. I hope that there was some notion of an answer in there about why VLMs and LLMs and what world models are broadly. So,
Yeah, well, so Sam, looking way more than just a notion, right? It's really each one of you guys are really helping building this kind of wall of information around real world models that are benefiting so many people. I mean, just for our reference, close to 140 people are watching this live, and so thank you for all of you decided to make time in the middle of your day, no matter where you are. So thanks, Sam, for this. So Aaron, I'm gonna back to you. I remember when the robotics unit in at Micro One initiated with you, right? In many ways, and I remember in some of our previous conversation that you mentioned, right, that sometimes the demos look impressive, right? But when you try to run in the real world, there is usually a big difference. The discrepancy is meaningful. This was a story that I think I heard from you back in the days when we started robotics, and I guess many progresses has been made since then. So if you consider the spectrum between where we see demos impress, viewers, and where you see the application real world, where are we? Are we making progress to the point that we are closing the gap more and more? Do you see this being a gap that is still not within closure? So what's your sense of it, Aaron?
Yeah, I think that we've seen some progress, probably not enough for real world deployments, at least autonomously, right? So I see this sort of a phased approach. I think you start with some sort of simple data collection. And let me actually take a step back here as it relates to world models. The way I see it is if world models are going to be used for some sort of physical and embodied application, it needs to have this very generalized foundation, right? So the same way humans kind of grow up and they get a sense for everything around them in the world and how to interact and manipulate certain objects and have navigation skills just by living and interacting, not necessarily learning any physics by text, but really just learning it through experience. We need to create new data, but also find ways to use existing data. I mean, if you found a way to ingest all YouTube data that exists today in like one moment, right? If you were able to find a way to take all of it, it would take, I mean, lifetimes to ingest, but if you found a way to ingest all of it all at once, you'd probably actually have a pretty incredible understanding for the world, um, generalized, right? And then if you can specialize that generalized foundation model and have it applied to certain environments and use cases. That's a good start now in order to specialize. So let's assume some foundational world model gets solved. In parallel to that development, we should start by specializing these environments. So let's take a mine, for example. If you want to have automation in mining, I think you start with specific, like lower level data being created within those environments. And then once you validate sort of what data there is useful and helps these models downstream, you can then move on to richer sensor suites and additional modalities within that same environment. And as you make progress there, you can start kind of deploying these systems in those environments as sort of test runs, like they may be fully teleoped. But slowly you start seeing autonomy in certain simpler tasks and movements, right? Like less probably starting more with navigation because we've done a better job solving that in autonomy and moving towards more complex manipulation as time goes. But I see it as like you really have to deploy eventually, even if you're not fully doing it autonomously and kind of aim to specialize within those environments. So to come back to your initial question, I don't think there's been enough progress made since we last spoke, which is probably at the end of last year about this.
Mhm.
Um, and we're still seeing lots of demos, which are impressive, but we need to probably start getting more of a generalized understanding so that you can start putting two and two together when you're approaching a simple task and you can kind of predict the next step needed. Once we start getting there, I think we'll see some more impressive autonomy. It'll probably start with again these lower level tasks, but I think we're probably 6 to 12 months away from seeing some real progress on those simpler tasks.
Fascinating, Aaron. And look, you kind of gave me a leeway into the question when I asked to Derek, right? Because Derek, Odyssey has been working on physical accuracy, if I understand this correctly, right? And so it's like converting what Aaron was saying to the point when you're measuring, right, in a world model, the gap between it looks right and it is right? How does it? How do you do that? What do you actually measure, or how do you actually measure that in the world model? Because I think these are question that is not easy necessarily to even posit, right? Because they represent a degree of complexity similar to what we're hearing from Arian in terms of the development is there, but not there yet to the point that we wish to see. So, how do you how did you tackle this conversation around physical accuracy, Derek?
Yeah, I think that's a really good question. And to be frank, the evaluation landscape is nascent, and there's not really one standard, which is something we're interested in. Today, we run a benchmark stack, and we're SOTA or state of the art across a variety of them. And we use different methods for different dimensions, right? You might look at physical plausibility, you might look at temporal consistency, you might look at from frame to frame, are objects consistent? Are they warping? Um, I think there's an important note here, and I want to plug some of our researchers' work. His name is John Sadeghi, and he is this eminent publication related to what we're calling Calibench. And I think at its core, you can have models that plausibly represent how the world unfolds, but that doesn't mean they're accurate. And you can have models that collapse to predict the most likely outcome. And it'll look convincing on a per sample basis, but overall, you're still going to be wrong. So you really need to start measuring how you simulate the physical world. Um, and what that means is models that are calibrated to represent the true probability distribution of outcomes. So if you think of like a ball on a Galtron board falling down all the pegs, it doesn't always fall the same way, right?
Mhm.
And a double pendulum swing can be chaotic. So to correctly simulate them requires a level of serial computation that propagates uncertainty forward and does not shortcut into just pattern matching. This reframes physical plausibility to like a visual representation that is convincing and you clear once to a distributional property that you keep proving over and over again. That helps you get away from producing like a plausibly looking outcome to something that actually represents the distribution of resulting states. Does that answer the question? I think,
Absolutely, absolutely, there, because almost like I would say with serendipity, right? Whatever you guys are sharing kind of gives me a nice bridge on where I like this conversation to go. But absolutely, and I appreciate a lot the way you were talking about probability somehow, because it reminds me of this very, very old quote, right? About probability is just common sense plus calculations, right? And it's interesting. I remember it was at the Museum of Science in Boston where I live, where you get to see a bell curve and you get to see this spheres falling in the center. And what will be the chance that it will distribute to the fat tails, right? And you will notice that the central part of the bell curve is filling up faster than the peripheries, right? And I think this is where probably there is some degree of plausibility, right? That becomes to some degree, I wouldn't say predictable, but I say there is some anticipation of plausibility that I think makes it functional. And if I understand that correctly. So this is fascinating there, right? Fascinating, right? Look, there is something you said that almost felt a natural conversation with Sam, right? And this is Sam, where my question goes. And I think this you're gonna help us to cover a ground that we haven't covered yet. So you were working at Luma AI before on generative video. How does it actually transfer directly to world model for robots, right? In other words, this is another area where people might not necessarily understand like I was asking before about gaming, right? What is the nexus between generative video and the work that you have acquired over those 4 years, right? And the transferability towards direct world models, because I think it will help us answer some of the proposition that also Darryl was making.
Yeah, great question. To me, it's not that you were working on text to video, text to image. I think taking a step back, right? Like, what are these models fundamentally, right? Like, they're multimodal models. They represent many different modalities, right? Image, video, text, audio, right? Like, anything can be ingested by these models, right? The way I look at a world model is that it's nothing but just a very, very robust data ingestion engine, right? And that's what all of the industry is trying to build, right? We're trying to build these incredibly robust data ingestion engines that are able to generalize to different modalities. um, you know, the reason why I am interested in 1X is that we have access to more modalities, right? Like, we have access to tactile information, we have access to a lot more sensory, very rich sensory, proprioceptive information, right? And I think that that's where robotics is very unique, right? YouTube and a lot of the open source web data sets, or open source or open um, data sets that are out there, they are limited with how many different modalities that they can really consider and really learn a rich representation over, right? The difference in robotics is that you have a lot of interactive information, similar to what Derek was talking about with gaming, right? Like, you can get a lot of different modalities, render them out, learn some rich representation over it. Robotics, you have even more, right? You're limited by how many sensors you can attach to a robot. The answer doesn't mean to attach more sensors to a robot. It actually means to attach increasingly less sensors to a robot. But once you have gone to a sense of strong level of autonomy. So I think a lot of the work that I was doing at Luma with video, image diffusion, multimodal models, unified models, right? Like, it's all, I think robotics is a very natural place for a lot of the multimodal researchers that were working on, just media gen to maybe transition into, right? Like, it's clear that media gen is at a very, very mature state. See dance, right? Like, there's a lot of models that are not solving the problem entirely, but like clearly making big steps towards it, right? And robotics is still in a very nascent state, and we, similar to going back to what Derek was saying, right? We actually don't even have good evals for it, right? Versus if
Mhm.
you think about the maturity of the evals that exist in LLMs, right? There's nothing to say that any of these tasks are less verifiable, right? In coding, in math, everything's verifiable, which makes RL really easy. In robotics, everything's also verifiable, which should make things easy, right? Which should make evals easy, but it hasn't, and we haven't gone there yet. We haven't figured out the evals yet. So I think a lot of multimodal researchers, all of the Bay Areas, really interested in robotics. It's not if they're not pivoting right now, they have thought about pivoting, or they're trying to figure out, how to kind of um, position themselves to be, the leaders in the robotic space or the embodied AI space. And it is, yeah, I think, the multimodal broad strokes, multimodal learning research is very, very applicable to robotics research, right? Because it's very similar, right? Like there's still images, there's still videos, but you have access to way more. You have bidirectional audio, you can have tactile information, you can have sensory proprioceptive information. So the amount or the richness of the representation you're able to learn is strictly superior with each sensor, each modality you add. Again, not saying to
Mhm.
add more sensors, that's never the solution. That's just
Yeah.
a loaded solution. If you need every sensor in the world, you have a bad solution. But you can still accomplish more because you have access to a lot richer representation of the data.
Yeah. So if I understand this correctly as well, Sam,
Mhm.
the on one side, the interoperability is an incredible form of advancement that we can actually pivot, right? But
Mhm.
that's also where indirectly the degree of complexity is increasing as well. Because now you have more interoperable variables to deal with, right? And so this is why probably back to the premise, why are we not making fast enough progress? It's not because we're not investing into this, but because we're expanding the ramification of variables that needs to be taken into account, right? And so this is fascinating because it will eventually get to a point where we might get, back to their point, a degree of plausible deployment that is good enough for general purpose technology to demonstrate its utility in real world tasks. But I also understand why there's a lot of transferability across different kind of skills, and
Yep.
that both advances us, but equally create a bit of red flags, right? Where we add in more dimension to consider.
Fundamentally, right? Like diffusion transformers are not new, right? Like they were like a 5-year-old paper, but people have built such impressive, data pipelines on top of it, and obviously modernized the ML stack itself, but also just built increasingly sophisticated data and infra pipelines around it, so that you can get more throughput, you can scale things up more. It is not brand new technology. It's about just general purpose or making this general purpose technology increasingly more and more powerful, which is
Yeah.
what which is why I think a lot of these skills are very, very transferable.
Great, great. So, folks, I should be looking at the question now. There's one that came. I'll try to kind of introduce it. It may be my last round of question to each one of you, and if more question are coming, I'll kind of try to model my question accordingly. But Aaron, I want to kind of try to build on the question we received in the Q&A about the quality of data that we use for training in a slightly different way. So, Micro One is a company that has been investing a lot on human data infrastructure, and I think, especially in the context of training frontier models, we understand that human expertise is so critical, right, for the success of the large language models in the real world. In the robotics world, in many ways, when do you need a human in the loop, right? And I know it's a simplification. I don't always like the idea of human in the loop, but it becomes easier for people to relate to that. So at what point in time do you find the human expertise is helping, like it is so clear, right, for large language model and expert, we're training the models. Where is the same conversion happening in your line of work?
Yeah. I mean, I really do believe that human in the loop is needed at every stage, and I mean, we're nowhere near human in the loop not being needed. I can't really even forecast when that's going to be the case when it comes to robotics specifically. So if you talk about where we're at right now, you can talk about it from a data collection perspective or a data structuring perspective, right? So, um, let's take human videos, right? There's going to be some sort of demonstration needed done by humans, but and you take the structuring side of it, let's assume you found a way to simulate autonomous data. You need humans to be verifiers on that data and see the assess the plausibility. You need humans to also, I mean, you can have some sort of video model structure this data. You can have it segment, you can have it annotate the actions going on, but you do need humans to assess the accuracy of that structuring happening. Let's take Waymo for an example, right? When
Mhm.
Waymo was doing self-driving, you started with humans driving cars around. That is a form of human in the loop to create data, and then you also, even if you're running simulation, which like a lot of FS and Derek can speak on this way better than I can, but there's lots of simulation data that was needed for FSD and still is, and it's highly dependent on that simulation. But when you simulate all these sort of edge cases that you prefer not to see in the real world, or are hard to replicate in the real world, you also still need human in the loop to um, verify the accuracy and like see how that simulation is performing. And so just from all angles, human is very much in the loop. Now, the type of expertise is kind of where I would like to draw the line. A lot of this early pre-training data doesn't need much expertise as you're ingesting so many different data types. You kind of can have just sort of a generalized sense of understanding of the world. And so we like to kind of call this profile a generalist, right? So somebody who can give their input on any sort of data type, but it's not an expert in the way where they're specialized in one domain. That is what I'm very excited for, in the future. Once you start to specialize these different form factors or task types, you can then, like when we get to some sort of evals in robotics, um, you would like to see a robot deployed in a special environment, say a dentist office, and
Mhm.
have those human experts in the loop kind of evaluating how they're performing at certain tasks, the same way you do with language models today.
Yeah, fascinating, fascinating. And look, thanks again. And there was a question from Abdul Aziz that was talking about the data that is required, but you kind of encompass that in the kind of hand-to-hand that we need to have with human expertise moving forward, right? So actually, the degree of progress of the robotics field is also proportional to how much we'll be able to use with human expertise accordingly, right? Which is something that Macron, I think it's part of our mantra, but it's something that sometimes people they think there's an inevitable trade-off, which we discovered is not. It's the opposite. We grow the capacity of the technologies, we're growing humans in the loop. So thank you for this. So some question that come, folks, right? And so there's one question that Derek seems to be almost perfect for what you said early. You were talking about causality, right? And there's a question I find it fascinating. So when do you know that a kind of world model has actually learned a causal structure rather than maybe just generating plausible next states? And I think I don't know who asked the question, but Haley has reported a question back into the chat. And I'm equally intrigued because I would not know how to answer the question, right? So when do you find the space between, yes, there's been a causal learning, or this is mostly a mimicking that is within the distribution of the statistical inference that we have?
Yeah, that's a good question, and I'll take a stab, but I think I would defer ultimately to our research team, who's far more
Sure.
intimately familiar. I think the Cali Bench publication that our researcher is going to come out with will help illuminate this space for sure. And I don't think it's either or. I think like plausibility is a step in the direction of then coming to understand the distribution of possible outcomes. And there's value in plausibility um, on your march towards a greater representation of possible outcomes. Um, but it's a good question, and I think ultimately, like seeing consistency inside of understood distributions from generation to generation to generation is ultimately the measure of success.
Mhm.
We can deliver something in the interim that is plausible and represents a likely state, and there might be valuable value there. But ultimately, seeing that distribution of randomness unfold consistently over multiple interactions of the model is ultimately what I think we would be looking for.
Great, great. Thanks for this, Eric. Sam, look at I guess it's Patrick, the first name, right? Asked two questions, but Patrick, I will choose one of the two questions. And look, the one I'm choosing is the one that is about a contrarian view, right? So there's been a lot of misconception when AI started to knock on the door, right, of general purpose technology, and people started to see AI for what it's not. So a lot of us, we had to demystify, right, the wrong information at first. Similar to the world models, robotics, and from your experience, what is one of the things that you learn from working from the inside that seems to be very, very different from what the public instead perceive outside, right? Where do you find that there is, I remember when people thinking I will take over the world, and we had this exterminator view, right? And people who are inside, especially data scientists, say, I don't know what you're talking about. This is statistic and computational power, right? Where in the robotics you find that we have a similar situation where the inside knowledge tends to differ a lot from maybe what the general public thinks?
Yeah, what a great question. Or I don't know if this is the last question, but what a great question to possibly end it off of. I would have to think a little bit. I think the interesting thing about robotics is that we are still like, fundamentally in such demo culture that I think it's kind of cool to see, right? Like you're able to raise so much money, right? Like VCs and stuff are just so excited to raise money or to spend money on just demos, right? Like whether it's like the embodiment or the physical demo, or just like an AI purely AI demo, um, or showing the AI capabilities of a robot, right? I think the demo culture is really cool, but I I don't know if this is a hot take because I don't know how many people have been paying attention, but I do think that demo culture is increasingly coming to an end. Like what we have seen with like as these general models have like started taking off, right? Like they kind of went from AI slop to AI pretty useful, right? I think that I wouldn't say we're categorically at that inflection point just yet, right? Like I think that I wouldn't say robot slop, but I think the demo slop that has been going on or plaguing robotics, or plaguing for better for worse, right? Because it is a very difficult technology to build, right? But I think the demo culture is slowly starting to end. We are at 1x, right? Like we're trying to sell robots at a pretty substantial scale, right? And I think whenever you think about how do we get data and how are we able to like deliver on get like increasingly new morsels of data, which is increasingly more useful, right? That is still going to be the case, right? Like micro one is still very well situated, right? Happy to chat about that at some other point. But we are also going to be able to scale up, like the live deployment data, right? Wherever we're able to get that data from. But we're actually going to have like, real robot interaction with the real world. It's not constrained by like, the studio that have developed, right? Or the form factor, or the house that have like, manicured up to do data collection, right? We're actually going to have deployments, and we're actually going to be able to scale up to at a rate which is pretty cool, right? And I think there's one is not the only company. There's definitely other companies that are also able to deploy these robots into the real world, which I don't think people actually have fully realized, right? Like these robots are very soon going to enter the cultural zeitgeist of just like coexisting with people, living alongside people, solving real physical problems in the real world, right? Like the state of AI is definitely not good enough for it to solve everything all the time with 100% success rate, right? But how can we basically like bridge towards that, right? Like where can we deploy these robots such that we're able to still collect meaningful amounts of data, but we're actually like making meaningful progress to the actual product, which is what obviously drives the consumer market, right? So I think like whenever we think about humanoid robots and robots broadly, right, we don't discuss deployment. We discuss capabilities. We discuss,
Mhm.
what it can theoretically do. I think it's going to be out in the display sooner than we think, right? Like we're going to have these robots in the real physical world around people, interacting, doing, real human-like tasks. Not as efficiently, not as fast as humans, not as correct as humans, but still, right? Like there's going to be the hill climbing function that we saw with LLMs, right? Like we saw that when ChatGPT came out initially, right? It was kind of cool because it could like kind of summarize things, and it could like, write Snoop Dogg haikus or something, right? There was like cute things that it could do. And I think we're very rapidly heading towards that moment. Which I don't know if that's a hot take or if that's something that's the insider take, but I do think that the deployment and the real world adoption is much sooner
Mhm.
than you would expect.
Right. So look, it feels naturally as a perfect way to kind of bring our forum to a closure. There kind of, you cover a couple of questions that were kind of floating around. One about, where likely in the next few years we'll see these models to take off, and you kind of gave your representation. And I think there was kind of within the narrative that you share also before, right? I think the question that Sai was asking about integration between robotics, world models, and gaming. We understand it. We also introduced the generative video. So we kind of figured out that that question was to some degree answered. There's a question from Lars that I don't have the time to run, Lars, because it's more technical, and I have to kind of close the forum. I'm already a few minutes past, but feel free to reach out, and I can always kind of ask Arian, Sam, and Derek to maybe take a step to your question as well. That said, I want to bring this over to a closure as kind of we want to celebrate the learning that you guys have helped us to shape and craft today. Lots that has been shared today comes from you working directly skin in the game and in the industry. I think there's a lot of excitement about what is ahead of us, but it's not an excitement that doesn't come with either red flags or with increasing degree of governance or accountability around this task. I think we're learning that we're making progress, but not fast enough. But it's also true that what is also slowing us down is that we expanded the interoperability across different technologies in a way that maybe we are not thinking before. It almost feels like that maybe the breakthrough will happen much faster when it happens, similar to when generative AI was in the labs, but the only happened at such a cosmic speed only after the release of OpenAI, right? And so maybe, right, that moment about breakthrough is not too far. Just that we never see this when we're still in the works. So, Arian, Derek, and Sam, thank you so much for having spent your day, well, your afternoon with us. Actually, for you, if you're on the West Coast, it's probably lunchtime. For me on the East Coast, is the beginning of the afternoon. We've been having over 140 viewers live all the time, on top of the one that will see us on the different channels, and really appreciate what you have shared with us. I hope it's not the last time we're going to be able to work together and get to part of this conversation. But on behalf of the Micro One Forum team, that we curated this series with the intention to try to disseminate as much knowledge as we can. Thank you very much for being part of that. And I'll close the works now, but I see you very soon, guys. Thanks again. Cheers.
Thank you.
Thank you. Bye-bye.
Bye.
Bye-bye. Bye.